Welcome, ladies and gentlemen, to Randolph Soundstage. I'm Randolph Tim, and in this series we're going to explore the world of sound. We're going to study what sound is, how it's made, how we hear it, and how to control it. This is my little home studio where concepts are born, experimented with, and ironed out before being taken into the studio. Remember, time is money. Studio time is real money.
Yeah, darling, gonna.
In this episode, we're going to examine some of the common equipment found in stage setups. We will take what we find here into the studio with us, where it will be very useful. Many of the tips and techniques will apply there also. I hope you'll join us for the future videos, and we'll be using what we learn here as a foundation so that we know what we're doing and we know what we're talking about when we walk into the studio and set up the stage. So with that said, here's all about sound. Microphones come in two basic colors, omnidirectional and cardioid. This refers to the pickup pattern. Omnidirectional picks up sounds from all directions, whereas cardioid picks up sounds mainly from its forward pickup pattern. For almost all stage situations, you will want a cardioid mic. Using omnidirectional on stage for anything that goes into the PA mains or other speaker is going to expose you to extended feedback problems. Microphones come in three different flavors, but you only have to worry about two, dynamic and condenser. Dynamic microphones are passive and just plug in. Condenser mics generally offer wider frequency response and better dynamic range, but require a power supply that can range between 5 volts and 50 volts. Most modern sound and mixing boards have a built-in supply for condenser mics, which can be switched on and off for each channel or bank of channels. Before plugging a microphone into a board, always make sure that the power switch is set correctly. Most boards send around 48 volts to the mic supply, which will damage a dynamic mic irreversibly. The primary purpose of the soundboard is to mix several sounds down to one for feeding to the PA amp. The original purpose of the PA was to amplify vocals so that they could be heard over the amplified guitars and drum sets. That's where it got the acronym PAs, which stands for public address. Somewhat similar to the PA systems at your schools. And originally PAs were used for stage symposiums, auditoriums, where you had a single speaker and maybe one mic, possibly two. And the original PAs only had 1 or 2 channels in them. 50 watts was high end. The original PAs for stage performance and for bands were generally around 6 channels, and before Mr. Rickenbacker invented the electric guitar, acoustic guitars were microphone and fed to the PA for amplification in large auditoriums, large venues. Back then, no effects sends or monitors were needed or included, and often the PA had built-in amplification like guitar amps, and you had a 100-watt PA or 150-watt PA. If you had 200-watt, you were moving right along. Today, 8 channels can get you by in smaller venues. Less than 500 if you don't mic the drums. If you have to mic the drums with drum mics for large venues or recording, you will probably want 12 or 16 channels. When figuring out how many you need, don't forget to count effects returns. More about this later. In the old days, the rule of thumb was you wanted twice the power going to the PA than you had from one guitar amp. It didn't really matter how many guitar amps you had. If you had too many, you cranked them back so you didn't drown the vocals. 100 watts on the PA was considered adequate for most small and medium-sized clubs. Guitars ran anywhere from 35 to 70 watts max, and you wanted everyone to have the same model so you could keep the balance. Hey Dan, what are you set at? Hey. Okay. So let's look at a block diagram of a common 16-channel layout. This is going to be a simplified version, but it should suffice to explain the basics. The first thing the signal enters is a gain control and a preamp. The gain control is there because different sources present different levels. There may easily be 100 to 1 difference in dynamic mic signal levels and line signal levels. These level controls are usually knob controls and are used to balance each channel to a standard level, usually 0 dB. We will explain more about this later. The signal from the preamp is fed to the channel sliders on the board, possibly through a 3-band EQ. There is one for each channel. At this point, the channels are monophonic. The sliders are used to set the individual level of each channel in the final mix. On stereo boards, there will also be a left-right pan knob or slider to adjust where you want that channel in the stereo pan. The outputs of each channel preamp are also fed to the effect sense and monitor level controls. This is so you can adjust the level of each channel to a particular effect or monitor. The outputs of each level slider are sent to a mixing circuit that mixes all of the signals down to a stereo signal for feeding to the PA amplifier, which drives the PA main speakers. Power amplifiers amplify the signals coming from the soundboard to power levels capable of driving speaker systems. Specifications of primary interest are wattage, which is the amount of power that the amp is capable of delivering safely, frequency response, which is the total bandwidth that the amp can deliver at full power, THD, or total harmonic distortion, which is the total amount of distortion that the amplifier will introduce at rated power, and noise level, which is the amount of internal noise generated without any input signal and is generally given in decibels below a 1-volt signal level. One other spec that might come into play occasionally is input sensitivity, which is the input signal voltage level required to produce a particular power level at the output. This is almost always designed and spec'd at 1 volt, which means that the 1 volt signal level at the input will produce the rated wattage at the output at the specified speaker or load. The amp's power is rated for specific speaker impedance, which is the load that the speaker system presents to the amplifier. Speaker impedances are generally designed in 2 ohm, 4 ohm, 8 ohm, and 16 ohm values and can be obtained from the speaker specifications. It is important that the speaker is rated at or above the amplifier power rating, or there will be high risk of burning out the speaker. Driving a 200 watt or 500 watt speaker with a 1000 watt power amp at full volume will cook the speaker coils in a New York heartbeat. It is possible to get more power out of a power amp than its rated power by driving a lower impedance, but check the specs of the amp to ensure that it can be done safely. We'll discuss this a bit further in a moment. The frequency response of the amplifier tells you how much of the audio bandwidth can be delivered to a speaker system at rated power. The audio bandwidth goes from 20 Hz or cycles per second to 20 kHz. Most good power amps will provide this bandwidth. We aren't going to get into subwoofer systems here simply because I don't recommend them for stages for a number of reasons. You'll be better off spending the money on high-end power systems. Decent THD is around 0.1% THD. 1% THD is okay, but you don't want to go over that if you want really high quality sound. Sometimes there is a trade-off between max power and THD, in which case you have to make choices. Speaker systems. High power speaker systems come in a variety of flavors and configurations depending on the amount of power you want to run and the quality of the sound you want to produce. Most speakers are multi-component systems with woofers ranging from 8 to 15 inches for the low end of the spectrum and horn tweeters for the high end, and will include an internal crossover network to send the right frequencies to the right components. High-end, high-power systems may have several of each component or be comprised of three-way systems which include a mid-range cone or horn. Again, make sure that the speaker systems you are using are capable of handling the power that you are driving into them. If the power amps are rated significantly above the speaker systems, you might want to consider fusing the speakers to prevent speaker damage. Some high-end amplifiers have adjustable output limiters to help with this. Let's move on to a couple of common effects for the stage. Effect units are driven from an effects send from the soundboard, and the output of the effects unit is returned to a channel input on the soundboard. So you adjust how much signal from each channel is sent to the effects unit or units, and then adjust how much signal from the effects unit get put into the mix. Please note that if you send a portion of the effects return to the same effects send, you are effectively, no pun intended, creating a feedback loop in the effects channel, which can cause problems. Make sure you have your effects sends adjusted properly on the return channels, which ordinarily will be none. Some reverb units may require some effects send signal from the return channel, but be careful. Too much return send can cause squeal or excessive noise from the reverb. I hope you enjoyed this piece of Randolph soundstage, and if I imparted a piece of useful information or sparked an idea, well, that's even better. Future videos in this series will explore other aspects of sound and sound electronics that are essential to consistently setting up a stage and getting the sound that works on stage or in the studio. Now you can subscribe to this channel or get notifications when a new video gets posted, around one a week hopefully, or you can check back to the Randolph Sound Studio playlist if you wish. Thanks for checking it out, and I hope to see you back soon. Feel free to check out the other videos and playlists that you see here, and please be kind.